Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to be talking about statistics and its relationship with probability. So today we're going to learn about how probability is used in the media and what that connection is to statistics. And you're successful when you can identify examples of the use of probability in the media and the different ways there where probability is represented there. Also, when you can interpret that information that involves probability and statistics, and you can make connections between those two ideas. So just to start us off, I'd like you to take a look at this infographic from phdcomics.com. Jorge Chen has made this all the way back in 2009. This is the science news cycle. So you start here where you have your research conclusion. A is correlated with B, P equals 0.56. Given C, assuming D and under E conditions. So there's a lot going on there. And that is translated by the university PR office, the public relations office. Okay, for immediate release, scientists, which I guess would be the guy who did the research, find a potential link between A and B under certain conditions. So they will release this information to the public saying this. That is then picked up by newswire organizations. And they write down A causes B, say scientists. Okay, it's not exactly what we said, but sure. And that is read by the internets. And people on the internet are saying, oh my God, I knew it. What the hell? Scientists are out to kill us again. And they post all sorts of stuff on blogs. Then that is noticed by CNC Cable News. We saw it on a blog. A causes B all the time. What does this mean for Obama? Breaking news. That is caught on the local eyewitness news. What you don't know about A can kill you. More at 11. A killer among us? And eventually this makes it to your grandma who is wearing this tinfoil hat. I'm wearing this to ward off A. And this is you who maybe did the research in the first place know that that is not true, or she doesn't need to be wearing this, or that it won't work, or that, A doesn't do anything like that at all, except under certain conditions. What do you notice about this whole science news cycle? Take a second to really think about it and see if you can come up with some things that you might notice. So you may have noticed that, like, whatever we concluded at the beginning with our actual research can get so twisted and can mean something completely different. And this is sort of what our news cycle is these days, right? Every single step that was taken was very close, but not exactly the same as the step previously. Like the university PR office, they did say potential link between A and B. They did say under certain conditions, but they put that in like very small writing. And so the newswire organizations are misinterpreting this just a little bit, but because there was already a little bit of a misinterpretation, now it's getting worse. And with every single step we take, the misinformation gets worse and worse. Let's take a look at an example of misinformation that happened in 2023. On October 11th in 2023, Austin Matthews of the Toronto Maple Leafs Hockey Club scored his 8th career hat trick. And a hat trick, if you don't know, is 3 goals in just 1 game. And he did this in the first game of the 82-game NHL season. So there's 82 games to play. He did this on game 1, which is quite impressive. He just set the tone for the rest of the season. And just 1 game later, in game 2, he did it again. He scored his 9th hat trick. And everyone was going crazy. By that point, he had played in 483 games, and in total, he had scored 305 goals. What would your reaction to this headline be? Right, this newswire organization or a blog might post something like Matthews is on pace for 246 goals. First of all, where are we getting this number 246 from? I think that they got this number from 3 goals per game, so 3 goals in his first game, 3 goals in his second game, multiply that by 82 games, and that would give you 246 goals. So they think that he is on pace, which means they are predicting that he will score this season 246 goals in just 82 games. What do we think about that? Take 5 minutes here, discuss this, think about this, see what you would make of this data and whether you would predict 246 goals or if you would come to some different prediction. So hopefully you had a chance to really think about this and you would have realized that, okay, he's done this 2 times in 2 games this season, but he's only done this 9 times in his entire career. Out of 483 games, he's only done it 9 times. So this is the sort of the equivalent of rolling a really lucky number on a dice. For example, we've been rolling 3d4. It'd be like rolling a 12 and then rolling a 12 right away again. It's very unlikely that those 2 things will happen. And in fact, if we are looking for what is the probability that Auston Matthews gets a hat trick, what is the experimental probability? Well, in 2023, 100% of his games have a hat trick. But this would represent the experimental probability, but it would be almost like taking it with a very, very small sample size. It'd be like doing research, but only asking 1 or 2 people what their opinions are. You cannot expect everybody to have that opinion, right? And if we look at his career instead, so for now we've got 483 games of data, we would see that 9 hat tricks out of 483 games is about 1.9%. So just about 2% of his games will be a hat trick. Now, as for predicting how many goals will he score this season? Well, his goals per game in 2023, he has 6 goals divided by 2 games is 3 goals each game. But in his career, it is 305 divided by 483. He scored a total of 305 goals in his entire career. And if we divide that by 483 games, we find out that he scores 0.6 goals per game. Not even 1. He doesn't even score a goal every single game. How can we expect him to score 3 goals every game for the rest of this season? It's going to be unlikely. And so we would say that maybe he probably won't score a hat trick every game, but it'd be reasonable to predict that he would score this many goals per game for the rest of the season. So that's 80 more games. These 2 games that he got a hat trick in, they're already in the books. He already has those 6 goals. So he would score 50 more goals this season. And my prediction would be then that he would get 56 goals this season. Okay, because we're taking his career goals per game and multiplying it by the remaining games. Now, obviously, this doesn't make for as sensational a headline as 246 goals. So it may not get people as excited. And that is sort of a problem with news media these days, is people are on social media, they're on TikTok, they're on Facebook, they're on Reddit, they're on whatever, and they're looking for things that are interesting. They're looking for things that make their mind go, ooh, that's fun. And unfortunately, realistic numbers sometimes are not as interesting. And we have to make sure that we understand probability and that we understand its connection to statistics so that we can look at some numbers and be like, that seems fishy. And we can dive deeper and realize what the truth is and go backwards along that science news cycle all the way back to the research itself. So in this lesson, we learned that statistics are related to probability. Just as probability experiments help us determine the experimental probability of something, which we could use to predict that event happening again, statistics are used to predict future events. Statistical data can be looked at as the same as experimental data. And we would collect that from real-world events and real-world information, and then use that to predict future events. Sometimes the media will do something called sensationalizing an event. And they do that to elicit a stronger reaction so that viewers will be more and more engaged. They want viewers addicted to their websites, to coming back to their websites, because they get paid from ads. And the more views something has, the more ad revenue that company will make. A really strong basis of knowledge and critical thinking skills can help us avoid this misinformation, which is a very important term. Right? We never want to be misinformed about things, and we also don't want to be uninformed about things. So we do have to read the news. We do have to learn what's happening. But we have to make sure that what we're learning about is actually reflective of the truth. Let's do a couple of examples of how we would use statistics to inform probability. So in the trading card game Magic the Gathering, there are cards that contain very special rules that interact with the main game's rules overall. Some cards will therefore offer greater benefits and abilities than others, and some combinations of cards, their rules interact with each other in a way that can be super powerful or helpful to players. This card here, Black Lotus, is a real card, although this is not exactly what it looks like, and it's very expensive. In fact, a mint condition version of this card once sold for over $30,000 US. In a recent tournament, suppose that decks that contained this card, this extremely powerful card, won 85 games and they lost just 15 games. If you play in 20 games, how many of those would you expect to win if you have Black Lotus in your deck? Think about this for just 2 minutes. The first thing we would do is add up 85 and 15 to find out that the total number of games played is 100. Now, if you're winning 85 out of every 100 games, that means you win 85% of the time. And if you're only playing 20 games, what is 85% of 20? Well, let's convert this from English into mathematical language. So 85%, the way we write this in mathematics is we use a decimal, 0.85. Whenever you see the word of, that means you need to multiply. And 20 games, well, that's just the number 20. And whenever you see the word is, that is equals. So 0.85 times 20 is equal to 17. So I would predict 17 wins out of 20. In this next example, Sally and Juan are playing a trading card game. Juan has a card in play, which means it's on the table. Right now it's active. It's called Kala, Fierce Hound. In the past, this is historical data, Juan has won 130 out of 200 rounds when Kala is in play. And he's won 44 out of 160 rounds when Kala is not in play. Now, if Sally has a card that disables Kala for 30 rounds, 30 out of the 50 rounds that they will actually play, they'll play 50 rounds against each other, and Kala will be disabled for 30 of them, how many rounds would you expect Juan to win? See if you can pause this video right now and take 10 minutes to answer this question. So one of the things that we have to consider when we're looking at a question like this, we have to look at what is Juan's win rate. And actually, there are two win rates. With Kala, it is 130 out of 200, which is 65%. We also have to look at without Kala. Without Kala, he only wins 27.5% of his games, 44 out of 160. So we clearly know that when Kala is in play, Juan has a better chance of winning. But out of these 50 rounds, he will only have Kala for 20 of them, because Sally is going to disable Kala for 30 rounds. So Juan is going to suffer. At the end of the day, how many wins is he going to come out of this with? Well, to get that answer, we need to find two other answers first. The first is how many times will he likely win when he does have Kala, And how many times will he win when he does not have Kala? To find out how many rounds he will win with Kala, we take 65% of 20. He'll win 65% of these games, so that is 0.65 multiplied by 20 rounds equals 13. So I would predict that he would win 13 of these rounds. But then he will also play without Kala for 30 rounds. And he will only win 27.5% of that. 27.5% as a decimal is 0.275. Of means we need to multiply 30 rounds. Now he's playing 30 rounds without Kala. So 27.5% of 30 rounds is, so that equals 8.25. Now, obviously, he's not going to win 8.25 rounds, right? You can never win a quarter of a round. You can either win the round or lose the round. So, but this is just our prediction, right? So we can take a decimal and we can try to understand what does that mean. That means that 13 plus 8.25 is 21.25, which is closer to 21 than 22. So we would predict that Juan is likely going to win 21 rounds out of 50. 21 rounds, you need to get at least 25 rounds to tie and more than 25 to win. So I don't think that Juan is likely going to win this game. Okay. And that's how I got that. 13 plus 8.25 is 21.25, which I'm rounding to 21. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.